Embedded chessboards. In a visit to a gallery, I saw a contemporary art painting such that the whole picture is full of checking pattern tiles, with alternating squares of darker and lighter colours. Though I was unable to appreciate how this painting was worth decorative dollar value, I envisioned plenty of chessboards embedded in the pattern. How many chessboards can be found in the painting? I was wondering. A chessboard is defined as an area of 8 by 8 tiles and must have a white or a lighter color tile at the bottom right corner. The painting has its strict orientation. One cannot rotate the painting to count, nor count a rotated area as a valid chessboard. I'm not going to use Python for this puzzle, I'm going to use C++. So for input, the first line is an integer n for the number of lines to follow. The following n lines are, each line is an independent test carrying 3 integers: row, column, and isWhite. So row is the number of rows of tiles in the painting. Column or col is the number of columns of tiles in the painting. isWhite is either 0 or 1, means false. 1 means true. It indicates whether the lower right corner of the painting is white or is a lighter color. For output, write n lines. For each test, write an integer showing the number of valid chessboards that can be found in the painting. So for constraints, a less than equal to row and col is less than equal to 10,000. And 1 less than equal to n is less than equal to 100. So for example, all of this input will become this. So there's 4 test cases. The first one is small painting, the second one is bigger painting, the third one is random 1, and the fourth one is random 2. Right, let's start it.